Welcome to the Microscopy Nodes tutorial for annotating data and scale your microscopy visualizations in Blender. Let's first load a quick dataset. If you need to learn how to do this, I have a separate tutorial just for loading your first datasets. But I will still put the link to this dataset in the description. And here we have our RPE1 expansion dataset. For this, it's useful to see that in the actual Microscopy Nodes panel, we also have the coordinate space that we're currently in, which is micrometers goes to centimeters. And this is because Blender always exists in meter space, which we then translate our actual pixel sizes into. So we can go, for example, to a millimeter is a meter. So here we have the actual Blender grid as well, where we can see the meters, and then we can see that this is smaller than the millimeter that this would be. And we can go to micrometer becomes a centimeter, which will make it 10-fold bigger, or micrometer to decimeter. And we can also always just go back to the auto button, which will set the most appropriate size. Additionally, this also says where the origin on load is. So we can switch between XYZ centering, which centers the whole volume in XYZ. We can put it at the actual origin so that it goes from X is 0 and Y is 0 up. And we can put it just in the center at the XY plane. But these are all things that are kind of inside Blender and how Blender parses scale. Often with microscopy data, it is amazingly good to communicate within the render what the physical scale of an object is. So for this, we automatically load the axes, which is an axis grid, where we can see right now it is this object with the white lines, where we have the number of micrometers per step that we can change. If we select the axes in the modifier. We can also turn on and off the grid. We can turn on and off the front face culling, which is whether or not the lines in the direction of the camera are being shown. And we can change the thickness of the line, how they're being rendered. And we can just select which specific planes to show as well. And so this is the basic way that we communicate scale within Microscopy Nodes, and then you can usually add in your legend what the actual grid size is, or you can add an actual text object separately and annotate this. That would be, you could do, for example, here text where we do tab to go into edit mode. We can do a 50 micrometer grid. Tab again to get out of edit mode, and then we move it. And then we have our grid size annotated in our actual image. However, there's also cases where we don't want the whole grid, we just want a scale bar because it's a much more minimal item and it often looks nicer. This is also supported by Microscopy Nodes. We can do that by adding an empty object like we have here, and going into the geometry nodes of that object, which is the programming language which defines how that object is being generated, where we have to make a new node tree, and then we can add from our Microscopy Node menu different annotation things. So the first thing I'll show is the dynamic scale bar, which renders a scale bar at the size of the current object. So we can scale this with S, and we can see what a certain object's size is. And we can see that if we go to 50, that we actually exactly fall into these grid lines. However, this does currently give a warning because there is not an orthographic camera. And this is actually the really important part to understand when annotating 3D scenes, and this is why there is normally a box and not a scale bar, is a normal 3D render has a perspective camera. So let's add an actual camera to show the point. I will align it to the view so that we see what we have. If we have a perspective camera, there is a lens transform that's applied to the image. And that means that lines that are closer to the camera will look wider apart, and lines that are further away from the camera will look closer together. So this means that if we draw a scale bar anywhere, it is not going to be true for every location in our scene. And this, so to actually make a scale bar accurate, you need to use an orthographic camera which draws essentially zero lens transform where all lines are parallel going into the camera. This may look a little bit worse, but it is effectively the only way to use accurately a normal scale bar. Also, what's useful here is if we go back into our geometry nodes, we can go into annotation. We can also say align text to active camera, and then we will just have it here so that we can just drag it around and align it immediately to our plane. If we want to fit exactly the size of this, we can put 0.5 in here, but what the other way to do that is to use with Shift A. I go into the add menu, by the way. I go into annotation. We can also do rigid scale bar if we want more control exactly over how it's being drawn. So we can say 50 micrometers in here with a size of 0.4, which is the Y size, and then we want maybe 1 decimal, and we can also change the actual unit of this. So 50 angstrom and it just becomes vanishingly small, and 50 microns, it's this size. So this is basics of annotation. There's, however, what is also a useful, and here we can also add a new scale grid if you want to make another scale grid, but this is actually easier. If you go into the axes, we can see that all of these things that we can change in here are actually being fed into also one of these blocks, so you can start combining things in there. One more feature of the axes that's also useful is, let's hide this, is that if we actually select the axes, we can also rescale and move this, and it should always remain the exact same, like the right scaling. So if you've cropped or masked your data, you can still rescale your axes and put it around your object, and it is still a correct scale representation. And then the last thing I want to show in this tutorial is the annotation of, let's go back to our empty, is annotation of time. So time annotation is also in here, and this takes the frame and puts out where you can add a period and the input unit and the output unit with a specific size. Right now, however, I don't have an actual time data set, but we can kind of spoof that right now by saying we have 60 seconds input and we want it out in minutes, and this would go up through time like this if we had a time data set, because then this frame number gets automated, and you can see that this actually breaks this data set because there is not a time axis in there. Okay, thanks for watching this short video on how to annotate your data in Microscopy Nodes.